This video is designed to give you the solution to the Phoenix Circus School problem. Before you start, you must have actually completed the Phoenix Circus School exercise, have your sheet or your answer sheet filled in and handed in to Google Classroom. So I take it that you've read the scenario, which is on the Phoenix Circus School student instructions, and you have studied the table of unnormalized data, which is on page 5 of 8. If you haven't, then pause the video and have a look at that now. So next we have a look at the unnormalized data sheet here. Again, we've left some blank spaces or there, fields, so you can see where the data is repeated. And you can see that Benjamin here, for a start, is doing 3 courses, and you've got James here is doing 1, and so on and so on. That means that the names on the left, that's the first name, last name, trainee number and date of birth, are all denote trainees, whereas the module name, level, module duration, completion date and results are all related to the module. So that's where the table split is. Where I put this white area, you can imagine all those columns underneath the white area and rows are actually part of the module table, and over to the left they're all part of the trainee table. So as you can see here, we've got our first column, and it should be on your answer sheet, full of all the fields or attributes for unnormalized form. So what we need to do is we need to look at, and we've already discussed the fact that there's a trainees right from trainee number all the way down to the date of birth, and that all describes a trainee. And we can give that a primary key. There you go. So there's a primary key, and we have a trainee table. So we can take the module number down and fill it with all the attributes for the module table. And again, we can attribute a primary key to that module. Now we've got a bit of a problem, because those tables, now the link has been severed. So we need to basically go back and look at the unnormalized data again, and we've got to see how we're going to resolve the problem of a foreign key or a composite key. So if you look at this table here, you will see that if you look on the trainee side, that the trainee Benjamin does 3 courses. So in order, if we put the foreign key in there or made a composite key in there, you would have to, every time that you added a new module, you'd have to have somewhere to store that particular module reference key. And we can't do that because we'd have to keep adding columns. But if we did it the other way around and put the trainee number into the module table, it would neatly fit next to all Benjamin's courses at the end, or next to the module number as a composite key, and you could do that for all the other trainees as well. So all we need to do then is, if we lower this down here, we need to put in the trainee number as a composite key, and it's a composite key and not a foreign one. We could put it to the end and make it a foreign key if it wasn't related to anything in that table. But obviously trainees take modules, and modules have trainees on them, so therefore they are related in some way. So all the attributes here should be described in some way by one or other of those keys. So that then is in first normal form. So now what we need to do is move on, and we've got to move to second normal form. Now you must be already in first normal form before you can move to the next stage. So all your tables on in the first normal form column must already be in first normal form to move to this table. And also, if they have only a primary key and nothing else, or a foreign key, and they don't have a composite key, then they're also in second normal form. So we can move this table straight across without any problem. That's already dealt with in second normal form. So we've got the module table left. So what we've got to do is work out whether the attributes that are non-key attributes, that's module name, level, module duration, data completion and results, are either related to the one primary key, that's the module number, or both the composite key, module number and trainee number. So I'm just going to move those keys out so that we can see how this is going to work, basically. So what we're going to do is take each one at a turn. Let's take the module name. Does the module name belong to, is it related to a trainee and the module number, or is it related just to the module? Well, the module name is nothing to do with the trainee, but it is part of the module. And let's go for level. Now the level depends on the module, and it doesn't really depend on the trainee. Although they can take them, it's not crucial. The module still exists without trainees on it, because it could be designed. There you go. And the module duration, likewise, I would say that it's related to the module only and not the trainee. Now we come down to the date completion date. Now that does relate to the trainee, because the trainee has got to be on the course for it to be completed, and it's also got to be related to the module, so we can just drop that in there. And the result also is dependent on the module and the trainee, so we can drop that there. So now we've got tables where we've got one relationship in the trainee table. We've got a relationship here of that what key there and that key there, which is a composite key, so that's a many, so that's a one to many, and we've got a relationship of a one here in the module table to the link table here and the many. So then that should be in second normal form. So now we're going to go over and we're going to try and look for third normal form. Remember that you must be in second normal form before you can move across, and we're looking for any non-key attribute here that could be separated out and made into a key itself. So it's a transient relationship. So there could be part of one of these tables that's only a transient relationship between it and the primary key. So if it was moved out into the separate table, it would describe itself quite on its own, but also it will remove any final repeated data. So let's go back and have a look at these. So first of all, we'll look at the trainee table and see if there's anything in there. So trainee number, name, we've got trainee number, first name, last name and date of birth. There's nothing there that's not solely related to the trainee number. So therefore there's no real candidate for transit keys there. So we go down to the link table there, which we could call results, and we've got a module number and a trainee number as a composite key, and there's nothing really there, date that I can see, or results that could be teased out. But we have got something in the final table, module. We've got the module number and the module name seems related to it. We've got level and module duration. Now we're going to have to look at the data again. So if I switch over to the data, and let's have a look at what sort of relationship we've got there. We've got the module numbers here, but we've got a relationship between level and module. Now look at how many level 1 courses there are. There's 1, 2, 3. And how many level 2? There's 1, 2, 3, 4, 5 level 2s. And there are 1, 2 level 3s. But if you look at duration with them, all level 1 courses are 30 hours in duration. I think it's hours. The level 2 courses are all 60 and the level 3 courses are all 100. So that means that we're repeating 3 times, in this case 3 times we're repeating 1 and 30, and we're repeating 5 times 2 and 60, and we're repeating another 2 times 3 and 100. So we need to go back then and separate those level and module duration out of that table, but we've got to maintain a link with the table that they come from, because that's sort of a transient relationship that could be pulled out to cut down on any repeated data that was in there. Okay. So then, as we can see, that we've decided that these are in second normal form, so they're in third normal form here. So we've got the trainee table, the one with the table with the composite key, which we called results, is already in third normal form as well. So we're going to move these over here. You've got module name there, we've got level, but we can also take out level and duration into a separate table, because remember, even though level, we're going to have 1, 2 or 3 as a number for the level in the module table, but you can, if you remember back, that module 1 was repeated 2 or 3 times, and module 2 about 5 times, and module 3 twice. Okay, so what we need to do is add a new primary key to the new table, which we could call I don't know, results or level. I don't know. We'll have a look later. And we've left a key behind, and that key is not composite because it doesn't really relate to the module name or the module number. So basically, it's foreign. So we place this little symbol in there. Now, if you're doing standard form, then you would underline all the primary keys, but you wouldn't do anything to the actual foreign keys. You could put it at the end. That's what I do to signify that it is a foreign key, and I put all composite keys together so that you can see that they are composite. Okay then, so we seem to have a link there, and we're going to look at the relationships now. So if you've got the answer there, then well done. You've done well. You've actually you've got the solution. But if you've gone a little wrong, then try and understand how we got to this particular stage. So now we're going to carry on, and we're going to look at the 3 tables we've got. We've got trainee, results, module, and module length. Okay, you could call it level. That's what I did, but that's what it seems to call it here. So we've got trainee, we've got results, and we've got module, and we've got module length. So now we've got to put one of these symbols here to represent the relationship. So we know that trainee here had only a primary key, so that's got to have 1 at this end. But we know results had a composite key in it, so it should be a one to many. And again, we've got a composite key here. A module had a primary key which was linked to this composite key here, but it also had a foreign key, but that foreign key was related to the module length here. So because it's got a composite key, we can put a many relationship on it, and because this primary key is related to this composite key, then that's going to have a 1 relationship. Now we're left with here, we've got a foreign key in here which is linked to the primary key in this table. So we have a many to 1 relationship. And I just checked that, and yes, well done, we've done it. So if you have that solution and you've worked out the correct keys for those, then you have succeeded. If you've got anything wrong, then just go through this video and try and understand where you've gone wrong. And if you still don't understand, drop into the next Google Meet and I'll discuss it with you.